Hello everyone, I'm Luwei and currently I'm a joint PhD student under the supervision of Professor Eric Cabrera at CCDS of NTU. Today I'm going to give a Sentic Labcast and my topic is Vanessa, visual connotation and aesthetic attributes understanding network for multimodal aspect-based sentiment analysis. This paper is accepted by the findings of EMM-NLP 2024, and here are the information of co-authors and their corresponding organizations. I'm going to introduce this study from the following four aspects. Let's start with background. So nowadays, on social media platform, there are too many text-image pairs, and conduct multimodal sentiment analysis on this user-generated multimodal content can allow their researchers or some government staffs to better understand their users' preference, behavior, and also their specific opinion towards some public events. And so, speak of the task definition of multimodal aspect-based sentiment analysis. It was like to extract the aspect or specific target within the given sentence and classify their corresponding sentiment polarity based on the text and image pair. For example, let's look at the left side. The text image pair is about the text is about what a wonderful weather, and we're going to discover the target is weather. And for the image, it was like the sky is getting darker and cloudy, and is going to have a big rain. So, based on the semantic meaning of the sentence and the image, it was like a sarcasm scenario. So the sentiment polarity of weather should be negative. And the motivation for this study can be concluded into 3 points. The first one is that current studies they are inadequate in capturing the sentimental clues conveyed by the aesthetic elements of the visual content. So in this work, we propose to utilize the aesthetic capture impression, aesthetic score, and some other kinds of aesthetic elements to extract richer sentiment clues from the image from the perspective of aesthetic attribute. And the second one is that these methodologies, they also experience difficulties in discerning the appropriate modality for multimodal sentiment analysis. In other words, they are unable to guide the model to know in which cases they should pay attention to both visual and textual information and under which scenarios they should be language oriented. And the third one is about these models. They are currently also unable to bridge the representational gap between diverse modalities. They conduct the cross-modal fusion via simple add, concatenation, self-attention, and etc. So before moving to our work, let's have a look on some of the preliminary. The first one is the conception of aesthetic score. Aesthetic score is actually a quantitative metric which evaluates the visual appealing and artistic quality of the image based on its compositional elements, color harmony, sharpness, lightning, perspective, overall balance, and exposure, and etc. In a word, the higher the aesthetic score is, the better quality or the more beautiful the picture is. And here are some examples on the slides. And another conceptions are the impression and aesthetic caption. Impression, it was like giving you a image and you need to describe what kind of emotions that this image evoked from your heart. Yeah, it was like ask you what does this image make you feel, think, or believe. And the aesthetic caption is like to describe the image's aesthetic quality from the perspective of aesthetic elements that we mentioned on the first preliminary aesthetic score. And here are some examples of the generated impression and aesthetic caption using our fine-tuned belief. So the methodology's abbreviation is Vanessa. Yeah, and this slide displays the overall architecture of our proposed Vanessa, and it primarily consists of three components: the multi-aesthetic attribute aggregation, self-supervised contrastive learning for image text relevance, and the dynamic token merge. And I will introduce them one by one in the following slides. The first one is about the multi-aesthetic attributes aggregation, and before we start this module, we need to do some pre-processing of our text image pair. The most important step is to generate the impression and aesthetic caption via the fine-tuned belief. And after we have all the textual information and visual information, we utilize the Roberta to extract the semantic features from this visual modality and use the clip to extract visual features from the image. And together they are fed into the multi-aesthetic attribute aggregation module. And in this module, the most important point is to construct the aesthetic aware multimodal dependency matrix to build the dependencies between these four different information sources, and then use this dependency matrix together with the four information sources: the sentence feature, visual feature, impression feature, aesthetic feature. Together feed them into the graph convolutional network to model the inter and intra dependencies between these different information features to help the model perceive the aesthetic attributes, the impression and the visual and as well as the textual features of our information source. After we pass the features into the multi aesthetic attributes aggregation module, the output of this module is further fed into the self-supervised contrastive learning for image text relevance module. And before feed them into this module, we utilize the clip to obtain the clip score of each text image pair. And the clip score is also a quantitative matrix which can verify the semantic relevance between the text and image pair. The higher the clip score is, which means the semantic relevance between the text and image is higher, otherwise it is not very relevant. So after we obtain all the clip scores, we utilize the Gaussian distribution to split these scores into different levels. And if the score's value is higher than specific values, then this sample is considered as they are positive samples. Then otherwise it is a negative sample. And after we obtaining all these positive and negative samples, we conduct self-supervised contrastive learning on them to pull the positive sample together and push away the negative samples to make the model be aware of which cases it should pay attention to both visual and textual modality, and under which circumstances it should only be language oriented. And meanwhile, we also feed the textual feature extracted by the transformer and the multimodal feature output from the multi-aesthetic attributes aggregation into the dynamic token merge module. And in this module, we utilize a density peak cluster KNN algorithm to conduct the cross-modal fusion to find the clusters that are the most representative. And then we use these clusters together to conduct a multi-head self-attention with the textual feature and then pass them into a series of feed-forward networks to obtain the final features. And this final feature is further fed into the is further used to obtain the aspect sentiment pair prediction. And this is the main result of Vanessa compared with a series of strong baselines, including some text-based and multimodal-based. And from this table, we can observe that Vanessa achieved the state-of-the-art performance compared to all the strong baselines, and specifically, it also achieves on 1.2% and 1.1% average improvement over the second best baseline AOM, which further verified the Vanessa's ability of extracting the implicit and explicit sentiment cues from their aesthetic caption and the impression, and also as well as the function of their self-supervised contrastive learning for image text relevance. And here are some other experiments to further evaluate the effectiveness of each component. The first one is the ablation study, and from ablation study, we can see all the components are important for Vanessa because suppose without any one of them, the Vanessa would have not that strong performance, and uh, we can see without the static multimodal dependency graph, the Vanessa yield a significant performance drop, which also further demonstrate that to modeling the dependencies between different information sources in this algorithm is quite important. And we also conduct a visualization to evaluate the effectiveness of our contrastive learning, and we can see the representation quality of the training checkpoint consistently become lower without the SSL ITR, which also further demonstrate that learning the semantic relevance between text and image via clip score and combined with contrastive learning is quite important for this study. And here is the case study, and from these two samples, we discovered that Vanessa consistently output the correct predictions based on the based on the prompt of the impression and their aesthetic caption, as well as the perception of the relevance between the text and the image, which further demonstrate the effectiveness and the efficacy of our proposed modules in this study. And lastly, we also conduct the visualization to explore the relationship between the sentimental relationship between impression, aesthetic caption, and our proposed Vanessa. And from these figures, we're gonna find that aesthetic caption are more important than the impression for guiding or bootstrapping the Vanessa to obtain their correct predictions towards the sentiment polarity. And this observation also can be discovered in the ablation study, because in ablation study we're gonna we find that without the performance um, without a static caption drops more significantly than the variant which without the impression. And lastly, let's conclude the limitations of this work. The first one is that since the four different information sources, sentence, visual, impression, and the aesthetic caption, they are all different information sources, which means the dependency graph should be heterogeneous instead of homogeneous graph. Because the homogeneous graph only have limited representation abilities. So one of the future direction of this study is to consider about how to construct a heterogeneous graph based on these different information sources. Another one is that the generated impression and the aesthetic caption is less inclusive because we know different individuals have different attitude or different attire or taste towards different pictures or different visual content. And more fine-grained characteristics of individuals should be considered into generating the impression and aesthetic caption, like personality, gender, cultural background, religion, and etc. Maybe in the future, we're going to utilize the MLLM to conduct the multimodal role play to generate more representational and user preferred aesthetic caption and impression for conducting multimodal sentiment analysis. Thank you for your listening.